Well, welcome. Thank you for joining us today for the U.S. Virgin Islands 2022 Seismic Workshop. It's been a while since we've done this. We're still doing it virtual, but thank you for taking the time to join us this morning or this afternoon, depending upon your time zone. I am Daryl D. Joshin, the Director of the Virgin Islands Territorial Emergency Management Agency. And we're going to spend some time today talking about seismic activity in Puerto Rico, U.S. Virgin Islands, and the British Virgin Islands. We have some great subject matter experts that have been with us for many years. They're going to come back and talk about some activity and some new individuals joining us also. As you know or don't know, we live in a very seismic active environment. We have two plates that constantly interact. We learn more about those. We have the Caribbean plate and we have the North American plate. They're in constant interaction. Of course, generation of earthquakes back in 2020. In Puerto Rico, down in the southwest corner, a lot of activity, a lot of concerns. I know Governor Bryan had reached out to me and asked me to look at our earthquake plans and even our tsunami plans and have communication with our legislature to the community to have awareness about what is happening in the territory in Puerto Rico and Commonwealth as potentially in the British Virgin Islands. So we are all together in the concern for potential seismic activity and knowledge. A lot of this is just awareness, but of course, the impact upon building codes. It could be airports, it could be homes, it could be schools. It's very important to have that information shared with our leadership, as well as those that develop the code for the Commonwealth of Puerto Rico, U.S. Virgin Islands, and the British Virgin Islands to develop stronger environments for us to live, work, and play. Additionally, earthquakes can generate the tsunamis, and we have local tsunamis, and we have regional tsunamis and long-distance tsunamis. So you hear about some active zones and some history back in 1867 that actually occurred in the U.S. Virgin Islands, and then activities that are way back when. In today's technology, we're able to reach out with mass messaging systems. I know Puerto Rico has one, I know Virgin Islands has one, and so the British Virgin Islands have one. So it's very important we communicate to the community, as well as we run drills and tests. I know we have the Great Shakeout coming up. You'll hear more about that for October 20th. And then in March, we also have a Carib Wave, which exercises tsunami systems, tsunami outreach, and awareness. So please take some good notes, ask some good questions, the opportunity to chat with the experts. And this is really a chance to focus on our environment here in the territory, the Commonwealth, and the British Virgin Islands, because together, be educated, communication within our community. Our youngsters, please, if you're youngsters listening to this, take it back to your families, your parents, your aunties. Let them know how important it is to be aware of our environments here and what to do. We talk about the drop, cover, and hold on response, but that should be drilled into us. Understand your environment at all times. Also, what elevation do you live at? Potentially along the shoreline. If you're at a threat area, what's your evacuation zone to go to if a tsunami comes through? In the U.S. Virgin Islands, we talk about getting up to about 82 feet above sea level and inland enough to be protected if that threat does come to be. And unfortunately, it's a real risk. So I think it's important that it's not just something academically we're talking about, but for our lives, our welfare, and the community, that we stay abreast of this activity. Last time we did one of these, I look back for the U.S. Virgin Islands, it was back in 1984. It was done on St. Thomas. I spent 2 days doing it in person. Of course, technology today has increased considerably. So please, with today's technology being virtual, get a chance to be together and learn together and ask some good questions together. So thank you so much for joining us, and I'll come back at the end and do a closeout. And again, have a wonderful time with us here at the 2022 U.S. Virgin Islands Seismic Workshop. Thank you.
My name is Regina Brown, Deputy Director of Planning and Preparedness at VITEMA. Like Director Joshin did mention, thank you all for attending and looking at our 2022 Seismic Workshop for the United States Virgin Islands. We're able to have this workshop this morning, thankfully due to the National Earthquake Hazards Reduction Program, which is a grant that we get every year through VITEMA. And one of the goals that we did want to put into our grant and continue to put in annually is to have a seismic workshop. We also are working with our National Tsunami Hazard Mitigation Program, who we partner with as well. So these are some two great champions that assist us in this initiative and continuous scientific and education to our community in both earthquakes and tsunamis. I will now proceed to the first speaker of the presentation, which is no stranger to the Virgin Islands, which is Professor Watlington. I will read his biography and then I'll turn it over to him for his presentation. Professor Watlington is a native Saintonian and serves as the USVI Science Representative to the National Tsunami Hazard Mitigation Program. He retired from the University of the Virgin Islands as a physics professor and researcher after 40 years in higher education. As principal investigator, he led the Anegada Climate Tracer Study. He was founding coordinator of VITEMA, the Virgin Islands established program to stimulate competitive research, and principal investigator of the Anegada Climate Tracer Study. Professor Wallington was co-founder of the Regional Association for CARICOOS, the Caribbean Coastal Ocean Observing System, and serves as a member of its board of directors and as a representative to the Integrated Ocean Observing System Association. He was the incorporator and charter project director of OCOVI, Ocean and Coastal Observing Virgin Islands, Inc., and serves as an associate to its board of directors. He was authored refereed papers on ocean circulation on Kikimjeni submarine volcano and on anticipating recurrence of an 1867 class tsunami, and is co-author of the book Disaster and Disruption in 1867, Hurricane, Earthquake, and Tsunami in the Danish West Indies. In 2014, the National Weather Service honored Professor Wallington with the designation Tsunami Ready Champion. In 2021, the Marine Technology Society awarded him its John P. Craven Mentor Award. He continues to make presentations about coastal hazards in short courses sponsored by VITEMA, as a guest lecturer in the Caribbean-wide disaster management workshops sponsored by the private sector, and as an occasional guest lecturer at UVI. Now I will turn it over to Professor Wallington.
Greetings, everyone. I'm Roy Watlington, as just introduced. Thank you for the introduction. I just would add to that by mentioning that I am a science representative from the USVI to NTHMP, but I should mention that Regina Brown is my co-representative to that body. Okay, so earthquakes. This is an overview of earthquakes intended to set the groundwork so that my other colleagues can give a lot of detail. And so I'll start with the very basic stuff. The definition of an earthquake. An earthquake, in Spanish, terremoto, is the shaking of the ground, as simple as that. The shaking occurs along surface and interior oscillations and in all three planes, in, out, left, right, up, down. Okay. The causes of earthquakes, well, it's motion, generally it's motion along tectonic plate boundaries and at subduction zone boundaries. It can also be along intraplate faults that's within a tectonic plate. It can be sometimes because of movement of magma within active volcanoes. As the magma starts to move in a volcano, certain earthquakes are generated and they can be felt. And more recently, not in this part of the world, but in the United States, for example, human activities such as re-injecting wastewater into fracking vents in various industries has caused some earthquakes as well. An earthquake can really change a person's or community's whole life in a very, very quick manner. You see pictures here of some historic earthquakes, some very deadly, some not so deadly, but all of them very destructive. You see Dominica, where a church was destroyed in 2004. The lower left-hand corner, you see Anchorage, Alaska, where one of the largest earthquakes ever on Earth occurred, affected downtown Anchorage, Alaska. Upper right-hand corner, you see people with their luggage moving away from their homes, going to shelter after the 2010 Port-au-Prince, Haiti earthquake. Center picture, a woodcut drawing of a church steeple broken and fallen in the 1867 earthquake in St. Croix. And lower right-hand corner, the presidential palace in Haiti in that January 2010 earthquake. So then let's talk about fatalities in tectonic plate related activities since 1842. If you were to compare the West Coast with the East Coast, and we hear a great deal about the big one coming to San Francisco and other great earthquakes on the West Coast, the Cascadia subduction zone, all of those things are very frightening, in fact. But if you were to sum up the deaths due to tectonic plate related motion since 1842, between 1842 and 2015, you'll see that fewer than 4,000 people lost their lives due to those phenomena. Whereas in our region, The number is much, much larger, made very large recently by the Haitian earthquake, of course, of 2010. And in this number, I would include, although it wasn't earthquake per se, but it was tectonically related, the volcanic eruption in Martinique in 1902. That was 30,000 people. But even if you subtracted the volcanic loss of life from the total, it's still over 300,000 people in our region that have lost their lives. And our region, you'll notice, is a lot smaller than the Pacific zone. And so I'm sure just a number of pictures. So there are unlimited examples of deadly earthquakes. With television, with social media, with all the wonderful communication devices we have today, we get graphic images and we get a lot of information about them, to the extent that we might be thinking we have more tectonic plate motion now than we had in the past. That is not likely the case, but nevertheless, these events are disturbing. So you see pictures here of various events, most of which did tremendous damage and caused lives. You see perhaps Director Jashin was there for the lower left-hand corner in Turkey in 2000. And although I don't show any live images of the Sumatra, earthquake of 2004, I gave you the wave path as it came in, and that resulted in the loss of more than 275,000 people. More devastation. Upper left-hand corner, one of the most historic and far-reaching earthquakes was the Lisbon, Portugal earthquake of 1755. That created a tsunami that came across the Atlantic and impacted the Caribbean and the east coast of the United States. Other pictures here, Najita in Japan on the upper right-hand corner. All of these are showing disasters that recently did great damage, upset people, and in many cases lost lives. In the lower right-hand corner, you have a picture of debris of the 2002 earthquake sequence in Puerto Rico, which I believe one of my other colleagues is going to speak more about. Earthquakes occur largely along the boundaries of tectonic plates, which are moving relative to each other. And here you have, maybe approximately 20 plates shown in this image. And right in the center, you see a tiny pink slab, and that is the Caribbean plate. Notice that our plate is wedged between two plates to the left, that's to the west in the Pacific, and two plates to the right in the Atlantic. Those are the North American and the South American plates. And if you to blow that picture up, here is our little Caribbean plate. All right, it's one of the smaller ones, but it is very active. Relative motion relative to the North and South American plates, is to the east. They are being subducted under us. Our plate is riding up on those. Similar subduction is taking place to the west in Central America, where the two Pacific plates are moving under us. But earthquakes also result from intraplate motion within a plate, along what we call faults, cracks, but that is still driven tectonically. It is pressures from global tectonic plate motion that is giving the energy for these earthquakes, whether they occur along the boundaries or in the interior of a plate. Some of the mechanisms are shown at the bottom, various kinds of fault moving, vertical faults, up, down, left, right, and so forth. They have names. I don't have enough time to get into it. And then what is very prominent in our region, both to the east and the west of the Caribbean plate, subduction, where one plate undergoes the other. Now, if all of these motions were smooth and well lubricated, we wouldn't have earthquakes. Maybe we'd have something like a general hum, a deep hum. But in fact, the motion is erratic, spasmodic, and so when the surfaces of the two plates bind and then finally build up enough elastic energy to break free, then that release of energy is experienced as an earthquake. And so now, if you were to put a dot everywhere where an earthquake has occurred in our region, and the size of the dot has to do with the depth of the earthquake, and the color of the dot has to do with its magnitude. And if you were to do that, you would notice a cluster to the right, a cluster to the left, that's to the east and to the west, a sprinkling of earthquakes to the north and a sprinkling of earthquakes to the south. What this image essentially does is gives you the outline of the Caribbean plate. It's one of the benefactors, I guess, of the earthquakes, although very often unwelcome ones. Next slide. Okay, so what makes this region prone to certain earthquake disaster? And for the most part, it's proximity. You know, we are near many close tectonic plate boundaries where the Caribbean and the North and South American plates interact vigorously on several fronts. One such is the Puerto Rico Trench, which is about 100 miles north of Puerto Rico and the Virgin Islands. Also, faults within plates that intersect important populated areas. If these things occurred far away from populated areas, we wouldn't be aware of them. But the region being fairly small and the surface, the areas where earthquakes can occur being so many, whether along plate boundaries or along at faults, earthquakes are felt. And also dormant volcanoes, regions that are near to dormant or volcanoes that are coming to life or are alive, much along the Eastern Caribbean and also in Central America. As I said before, as the magma moves inside of these volcanoes, earthquakes can result. And so if you look from the east, an aerial view from the east with the water removed, you see our Caribbean plate. At the top of the picture, there's Central America. To the bottom of the picture, there's this dark blue chasm, and that is the subduction zone area. In the vicinity of Puerto Rico and the Virgin Islands, we call that the Puerto Rico Trench. And then you see the chain of islands running along the lower portion of this image, going all the way down to Grenada, where there's a submarine volcano that gives earthquakes when it's coming to life. Every few years, it seems to do that. And there are subaerial volcanoes, such as the one in St. Vincent that came to life last year and not only gave earthquakes, but also erupted. And then in our Virgin Islands Basin, there are faults that also give rise to earthquakes. And so some of these earthquakes that have occurred both in our immediate region and farther away have really been astounding. For example, just in two months of 2010, 2 deadly earthquakes occurred. First, January 12th, the Haitian earthquake. This image shows Haiti, and the red area shows the area of maximum shaking. There's a little star there you might see, and that's the epicenter of that earthquake. Over 220,000 people lost their lives in that. On the right-hand picture, you see that's actually indicating tsunami moving away from the South American coast at Chile, where another earthquake occurred on February 27th. It took approximately 700 lives. And so, and although somewhat less deadly, our region has experienced several other notable earthquakes as well. In 2007, a magnitude 7.4 earthquake occurred off the east coast of Martinique. According to the Seismic Research Unit of the University of the West Indies, this had been the strongest earthquake until the Haitian earthquake of 2010. Before that, in 2004, an earthquake damaged that Catholic church that I showed you before. That was a magnitude 6.0. And so we talked about, I just mentioned magnitudes of earthquakes. So what is this magnitude scale that we're talking about? It's called a Richter scale. Okay, it's a scale that we essentially measure earthquake energy, released earthquake energy. And on this scale, where the weakest felt would be a magnitude 2, there are some really record earthquakes recorded. Chile in 1960 produced the world record-setting 9.4. Alaska in 1964 gave a 9.2. Sumatra, which we remember, in 2004 gave a 9.1, and the Japan earthquake of 2011 was a 9.0. The Haitian earthquake that we experienced in 2010 was a 7.0, and the Danish West Indies earthquake of 1867 that caused a tsunami has been estimated retrospectively as between a 7.2 and a 7.5. Okay, now this is another scale. I don't mean for us to get into this in much detail, but just to let you know it exists. Similar to how the Fujita scale for tornadoes is used, the modified Mercalli index, or the MMI, indicates the amount of shaking, the extent to which it is felt. To distinguish it from the Richter scale, they don't use Arabic numbers 1, 2, 3, 4. They use Roman numerals, I, 2I, V, X, and so forth. And so you see the range. It goes from a Roman numeral I, which is a 1, to a 12, and it's quite broken down. You could see that by the time that you don't start feeling them until maybe in the range of a magnitude 3, that's I. But by the time you get up to a magnitude 9, IX, the damage is considerable. And it's past the point where people are frightened, where things are shaking. The damage is considerable. We cannot imagine what would happen if we were experiencing an earthquake that generated a modified Mercalli index of Roman numeral 12. And so there's some descriptive words that I should mention. I use epicenter quite a bit, assuming that that everybody's hearing this has a feeling for what that word means. I should also mention focus or hypocenter, mention P waves and S waves. Well, the epicenter is simply the name of the location on the surface of the Earth above which the earthquake is taking place. Okay, that would have coordinates like north and south coordinates, east and west coordinates, right? Below that, at the actual location in the Earth's crust where the earthquake is taking place, that is the focus or the hypocenter. So if you knew the focus, you would have essentially 3 dimensionals. You'd know the north, south, east, west, and you'd also know the depth. With regard to P waves and S waves, earthquakes generate a number of different kinds of waves. I point out the P waves and the S waves because these are the ones that we experience, and they're also useful in identifying where the epicenter of an earthquake may have been. P waves are compressional waves. They move where the vibration is parallel to the direction in which the wave is propagating, and S waves are transverse, meaning that the vibrations are perpendicular to the direction in which the wave is propagating. S waves are slower than P waves, and so the difference in arrival time between a P wave and an S wave can be used very simply with some geometry to locate the epicenter of an earthquake. And then direct results. We know these only too well. Of course, buildings collapse, things fall on people, objects fall, there's disintegration of buildings, dams, and other critical structures. The ground may break open in some areas, breaking within the Earth's surface, maybe fairly shallowly. There'd be rupture of water mains, gas mains, communication, and sewer mains. There's liquefaction of the soil. That is when the soil particles lose their cohesive forces. They don't stick together very, very well because the vibration of the earthquake is breaking their bonds. That results in the dissolution of compacted sediment and the loosening of foundations which may be placed on those sediments. Landslides can occur, rock falls can occur, precipitous boulders can be dislodged and roll down on houses or on roads. And there are secondary effects as well, such as fires and caused by the disruption of our infrastructure. Pipes are ruptured, both the gas mains are ruptured and the water mains are ruptured. So a fire might break out, but then you don't have the water to fight that fire and so forth. The images show in the upper right-hand corner, you see horses dead from falling bricks in the 1906 San Francisco earthquake. And the lower right-hand corner is a picture from Japan, shows that where a portion of a road has just fallen, probably due to slumping, almost right down the center line of the road. The lower picture in the center shows a building has collapsed upon a car. Among the secondary effects, by the way, are tsunamis. Okay, and so liquefaction and slumping, let's just talk about that. Because the soil has been disturbed and it lost the ability to sustain buildings, you'll have buildings collapsing, tilting backwards or shifting one way or the other, such as in this picture from Japan in 1964. Upper right-hand corner, you see slumping, where a whole section of the road has fallen off. In the Caribbean, where we have steep roads and roads that maybe have not been engineered maximally or optimally, you'll have some of this happening as well, although seldom as dramatic as in that upper right-hand corner. The lower right-hand corner, you see in Caracas, Venezuela, where liquefaction of the soil underneath this large building caused a portion of it to be not adequately supported, and so it fell to the side. Secondary effects, well, as I mentioned, secondary effects are fires. The lower left-hand corner picture shows people in the street looking down the road towards where fires are burning. If you notice in the foreground, the buildings have been destroyed. This is after the earthquake of 1906. Now the people have to endure the next part of that tragedy, and that is the fires that would do just about as much destruction as the earth shaking in the earthquake. Hazardous materials and pollution can result. Sewage treatment plants can be disrupted. Chemicals can be spilled. Fuels, for example, would be a good example of something that would be spilled as a result of an earthquake. In the aftermath, unhygienic conditions may prevail, such as decaying organic matter, dead animals, dead plants, liberated sewage, as I said, and this can cause disease, and we've had that example happen in our region. And then, of course, there's tsunamis. This image to the right shows, artist's conception of what happens if you don't pay attention to the shoreline when an earthquake has given you an early warning sign. And so there are many avoidable earthquake hazards, such as the one I just alluded to. First of all, unreinforced buildings and pathways. Many historic, such as in the historic districts of the Virgin Islands and Old San Juan. These buildings were put together with various kinds of masonry hundreds of years ago. The masonry, of course, has deteriorated a great deal. In some cases, for aesthetics, we have removed the plastering from these buildings so that we could see the raw brick, which is attractive, colorful and attractive, but this renders the walls all the more insecure. And so this one picture in the left shows one of the alleys, one of the commercial historic alleys in Charlotte, Amalia, St. Thomas, which would not be a good place to stand during an earthquake. We really are aware that in a large earthquake where the epicenter is somewhere near to downtown Charlotte, Amalia, many historic buildings that are unreinforced may perish. The center picture shows where a number of rocks have fallen from a cliff, fortunately not on anybody's house, but in many cases, precipitous boulders can be identified, and that's why I call these hazards avoidable. They can be identified and supported in advance, so when the earthquake occurs, those boulders do not roll loose. The right-hand corner, that was a picture in an office I had sometime, and I had these tall bookcases that went way up with heavy books such as, Merriam-Webster Dictionary up at the top. And when I looked, I didn't know when I first loaded with books, but these shelves were unsupported and my desk was right below that. In a moderate earthquake, those books could have fallen off and done damage to me, or the shelves could have fallen. And throughout earthquake-prone areas, you'll find people being unaware or careless in this regard. Lower picture shows a school that St. Thomians and others are aware of. That's Adelita Conquine Junior High School. Population at max would be about 900,000 people. At the moment, it is not being used because the hurricane damaged it and it's being put to other use, but it is built on filled land. Where that building stands, when I was a boy, the ocean was actually lapping on the shoreline. So these are all areas that are earthquake hazards that can be avoided if enough energy and funds are put into it. And so there are many local historic and potentially eventful earthquake sources in our region. One or more of my colleagues will speak about these, and some of these stars show events of the past. But I'm going to focus on the star in the right-hand corner. That's 1867, where in the middle of the Virgin Islands Basin, that's the Anegada Passage extended, we had the great earthquake of 1867. And so 1867, things were quiet in early October in 1867, which the islands were then not the US Virgin Islands, but the Danish West Indies, owned by Denmark. The tranquility that I just described was disturbed in 20 days of eventful activities. First of all, a letter came from the Danish king, Christian IX, in which he had just written to the people of the Danish West Indies, informing him of his hope to sell St. Thomas and St. John to the United States Virgin Islands as a transfer from Danish to American rule. As a result, Danish and American envoys were gathering in St. Croix for sale negotiations. And what this brought was a large number of American and some more than usual, a larger number of Danish vessels in the harbor, and many other international vessels as well. And then on October 29th, the San Narciso hurricane swept in from the east without warning. A small hurricane, it didn't affect St. Croix very much, but it went right through the British Virgin Islands and through St. John and St. Thomas and went on to Puerto Rico. By the time it was done, it took between 500 and 600 lives and left the Charles Amalia Harbor, that's the lower right-hand corner picture, in shambles. And in the British Virgin Islands, the center picture, it set that historic passenger vessel, the Rhone, to the bottom of the ocean between some of the BVI islands. Today, that wreck, parts of that wreck, are still there and are being visited by scuba as a tourism attraction. You'll see people wearing T-shirts saying, with this picture, and saying, "I dove the Rhone." But on the Rhone alone, between 150 and 160,000 people, 150 and 160 people lost their lives. Next slide. And so just as the islands were recovering from that hurricane, just 20 days later, at 2:50 in the afternoon, a major earthquake occurred. Okay. This shows a church steeple toppling, buildings were destroyed, roofs were collapsed, and some people were killed. There was wide-scale panic. This was the great earthquake of 1867. What followed next, resulted from the earthquake, was the historic 1867 Danish West Indies tsunami. The quake occurred about 30 kilometers, that's about 18.6 miles, below the bottom of the Virgin Islands Basin. That's the deep chasm. That's an extension of the Anegada passage, which comes in from the Atlantic past the BVI and terminating here in the Virgin Islands Basin. It's about 30 miles wide. The distance from St. Thomas to St. Croix is about 20 miles. You see Puerto Rico in the foreground. This is a view looking to the east. The BVI are in the foreground. And someplace in an approximate location where these circles show is where the earthquake occurred. The Virgin Islands Basin, by the way, is one of the deeper regions in our immediate area, and it's about 4.5 kilometers or 2.8 miles. Okay, and the outcomes were many, and I have to be very brief here. But of course, you would imagine the earthquake did a lot of damage and did cost some life. The tsunami further ruined warehouses, destroyed vessels, and the two together added to the disruption of commerce for many months. Among the vessels damaged were several U.S. military vessels, and that had some implications in terms of the relationship between the United States and the Danish West Indies. The loss of life was moderate with the earthquake and the tsunami, especially when you compare it to the more than 500 people that had lost their lives 2 weeks earlier. Estimates are between 24 and 30 people. A number of interesting, fortunate factors resulted in that relatively low loss of life. But the earthquake and the tsunami promoted the spread of yellow fever and other infectious diseases in the aftermath, causing additional cost of life. It did have impact on our understanding of building structures, and so building requirements and insurance for wall buildings, that's, masonry buildings, became an issue. The purchase of the islands by the United States was delayed until 1917, 15 years, and it may have been a result in part of this event. And so as I get near finishing, I want to tell you that the 1867 earthquake revealed many serious contradictions. And I just want to do a little segue into building codes and insurance, just some interesting developments. Prior to 1867, because of fires that occurred from 1804 to 1831, that plagued downtown Charlotte Amalie, St. Thomas, Christiansted, St. Croix, and elsewhere, many buildings had been of wood frames, and it allowed fires to spread very rapidly. Insurance rates, therefore, favored wall buildings, masonry buildings, stone, brick, coral, rubble constructed. So before 1867, building codes called not only for widened streets, but also limited the addition of new wood structures, favoring fireproof roofs that of tile and later on galvanized sheeting. And there was pressure requiring that if a new frame building was built, it should be separated from the neighboring buildings by a wall to prevent the spread of fire. However, after 1867, after masonry buildings had disproportionately been damaged by the earthquake and aftershocks, well into the next year, many people were afraid of sleeping within the walls and under the so-called fireproof roofs. For several months, some people camped out in tents, and the public discourse, new debate occurred, calling for building requirements and insurance rates that reflected that maybe wall buildings, stone buildings were not so safe, and that lessened the prejudice away from wood frame buildings. Now, years later, very conversely, after Hurricanes Hugo and Marilyn shattered many wooden structures and ripped off many roofs, you find people wanting to go back to concrete roofs and stone construction or tile construction. So natural hazards such as earthquakes and hurricanes can actually affect the extent to which how we interpret our building codes and our insurance requirements. I bring you to the events of Puerto Rico 2005, which are very well described in a YouTube video that's available, and I give the link there. The YouTube webinar was called Engineering for Disaster in the Caribbean. It was on 2 occasions. In part 2, Dr. Jose Martinez Cruzado of the University of Puerto Rico, a structural engineer, gave this example. He showed the building on the left, where after a 5.8 magnitude earthquake on January 6th had shown structural damage in its stilts. And the issue here is stilts. And that yellow arrow points to where cracking in the concrete surface around the steel in the stilts had occurred. But the very next day, a magnitude 6.4 earthquake caused those stilts to completely collapse and bring the building down. So this is an example of where, natural hazards make us aware of things. For example, and this is also an example of a conflict in preparations. The owners of this house were probably very pleased that the building was elevated to the extent that storm surge can flow under the building and not affect the residents, or even tsunamis might flow through and flow past. But preparing for a storm surge and earthquakes created a new hazard, especially when the building codes were possibly not followed rigidly enough. And so what do we do in an earthquake? We duck, we cover, and we hold. We do not run outside blindly from buildings because things might be falling from the building. If we're outside, we move away from the building. If we're near the sea, we look to the sea, we look for the natural warning signs. That is, the earthquake itself would be a natural warning sign. The erratic behavior of the ocean might be another. And roaring. I understand that as tsunamis occur, you hear the roaring of the sea as debris is moved on the seafloor. Well, if the earthquake lasts 20 seconds or more, you have to be careful. So those are called the natural warning signs. And here are more pictures of it. You duck, you cover, and you hold. The middle image shows areas where the collapsing of an upper floor, lives could have been saved if they were under that desk or next to the desk. I showed the picture at the right-hand corner of the historic alleys in St. Thomas. You don't want to stand there. Don't stand there. And the lower right-hand corner shows the outside of a building having collapsed. This is in Christchurch, New Zealand. And this is the reason why you wouldn't want to stand next to a building during or after an earthquake. And so in closing, I just want to give these examples. This shows comparison of the Indian Ocean to Japan, 2011, and the Virgin Islands Basin earthquake of 1867. And the loss of life and the amount of damage reflected a number of factors. One was preparation. In the case of the Indian Ocean, there was poor preparation. There wasn't enough widespread education about the threats of earthquakes and tsunamis. There was no regional warning system. The overall outcome was that it was as bad as could be expected. In the case of Japan, preparedness was excellent. Japan is a country that gets a lot of earthquakes. It's a fairly wealthy country, and it can prepare very well in advance. And so even though the earthquake was 9.0 on the Richter scale, the loss of life was relatively, I don't want to say that 15,000 to 9,000 people is a small number, but the potential for being in the hundreds of thousands with that sort of an earthquake was great. And and so excellent preparedness in Japan. In our case, a lot of luck came to bear. The earthquake was 7.2 to 7.5 on the Richter scale. We had no preparedness and no warning, but we had some fortunate factors: low coastal population and an excellent time of the day for an earthquake to strike our region. Because at 3 o'clock in the afternoon, people are not on the shoreline, so the tsunamis that accounted for most of the fatalities would not impact them. Key factors: preparedness, population, proximity, how close you are to the epicenter, how deep in the earth the focus is, and the actual magnitude of the earthquake. Thank you. And here are some references that I hope will be available if this is recorded and stored and available.
Thank you, Professor Wallington, for that very detailed and informative presentation. I will now proceed to introducing our second speaker, Dr. Elizabeth Van Cor, who is an associate research professor at the University of Puerto Rico at Mayagüez Department of Geology and the Puerto Rico Seismic Network. She received her Bachelor's of Science in Geological Sciences from Virginia Tech in 2003 and her PhD from Rice University in 2008. She held postdoctoral positions at the Australian National University Research School of Earth Sciences and the University of Leeds before joining UPRM in 2014. Her current research encompasses a variety of seismological research ranging from an array of seismology, real-time network operations, ground motions, and tsunami hazards. Currently, Dr. Van Cor serves as an international role for the tsunami preparedness in the region as the current task team leader for the Carib Wave exercise, vice chair for the Carib EWS Working Group 3 Tsunami Services, protocols for end-to-end communication and dissemination of warnings, and a Caribbean representative for the TOWS Task Team for Tsunami Watch Operations. She's also currently an associate editor for the Seismological Research Letters. With further ado, I'll turn it over to Dr. Elizabeth Van Cor, who will make her presentation at this time.
Good morning, good afternoon. My name is Elizabeth Van Cor. I am going to give you a slight presentation, a little bit more about some of the seismic hazards we face in Puerto Rico and the Virgin Islands, and discuss more the role the Puerto Rico Seismic Network serves for the Virgin Islands. So I'm going to say yes, I did make this talk, but I do want to credit the other staff and students here at the Puerto Rico Seismic Network who might see some of their images popping up in this presentation. So let's focus back on the hazards we face in Puerto Rico and the Virgin Islands. In general, you think we have the plate boundary to the north with the Puerto Rico Trench. The Puerto Rico Trench would be the simple plate boundary. However, you might notice that you have these different colored lines going throughout Puerto Rico and the Virgin Islands. These represent some of the major faults in the region. Here, the red lines are thrust faults where they have convergence. The orange lines are primarily our strike slip faults, similar to the San Andreas, where you have the movement moving next to each other. And the yellow lines represent our normal faults, where you have divergent motion of the plates. And we also have a number of different historical earthquakes. We've already heard about the 1867 event, and the 2020 event we're going to talk about in a few minutes. We also have the 1918 event in Puerto Rico, which also generated a tsunami. 1943 and 1946 other events in the region, as well as the 1787 event, where the 1787, their estimates of the magnitude of that event go from about 6.9 to about 8.5, depending on who's researching which historical catalog you look at. The key takeaway, though, is we have events or large significant events and earthquakes throughout the region, not just along the Puerto Rico Trench. So essentially, our plate boundary is what I would call a broad plate boundary, where instead of having a clean single line, we have a deformation zone that extends from the Puerto Rico Trench in the north to the Muertos Trough in the south. So essentially, Puerto Rico and the Virgin Islands, we're in the crumple zone of the Caribbean plate, similar to a crumple zone of a car during a car crash, which means that we have highly complex faults throughout the region, going both through our islands and surrounding our islands. The other thing I want to take a note of is the gray box in this figure. This gray box represents the Puerto Rico Seismic Network area of responsibility. So that means all the earthquakes in this region that are detectable and locatable will be located here at the Puerto Rico Seismic Network. So I mentioned the 2020 sequence. The 2020 sequence is an ongoing earthquake sequence in Southwest Puerto Rico. Currently, our catalog completeness is about 2 or so, is in the southwest Puerto Rico region. And that is essentially because there are thousands upon thousands of earthquakes. And each one of these earthquakes are located by hand by a physical human here at the seismic network. So you can imagine how much work that is for our seismic data analysts, and doing an incredible job with handling the sequence. Currently, as of yesterday, we have over 19,500 events that are associated with this sequence. And of those events, over 350 of them were magnitude 3.5 or greater. And to note, the last significant event happened back in August with a magnitude of 4.2. So the sequence is not done yet and will be continuing on the order of years. So a little bit more on this sequence. This sequence is not occurring on one fault. It is actually occurring on multiple faults. You started out with a number of events that were strike slip, and then it converted into events along a normal fault, and then we have a combination of strike slip and normal faulting in the region. A number of these faults on the order of 10 to 15 kilometers in length. So these are relatively small faults. So it's what we call a fault zone, where we have some major faults like the Punta Matava fault that plays a role in the sequence, but most of the activity is occurring on these smaller faults that are interacting with each other and expanding out in time. And that's what you kind of can see in the movie on the left. You can see that the earthquakes start and they gather in areas, and then they move somewhere else, and they just bounce around a bit in the region. So this is what you want to look at. Now, if you look at the sequence in 3D, you notice that there isn't, again, a single fault trace that appears. And that's what you want to take away from the information about this sequence. It is a highly complex sequence occurring on a number of faults, including both normal and strike slip faults. So this is the type of complexity that we see in our region and we deal with at the Puerto Rico Seismic Network. So what is the Puerto Rico Seismic Network? Well, the Puerto Rico Seismic Network, it's our job to monitor, determine the location and magnitudes for earthquakes in the Puerto Rico and Virgin Islands region. We also support the Tsunami Warning Center, in our case, for Puerto Rico and the Virgin Islands, Pacific Tsunami Warning Center, in the determination of tsunami alert levels in our area of responsibility. Not only do we have to determine the location and magnitude, we also need to inform and disseminate this information, not only to Puerto Rico, but also the Virgin Islands in a reliable and timely manner. So that is our job, essentially, as part of the network. We also do things such as investigation and education outreach. I'll talk a little bit about that later. But I want to talk first about seismic monitoring. And I want to highlight this because we cannot exist as a network without the people at the network. This staff includes permanent staff. This permanent staff includes administrators, educators, information technology, field technicians, data analysts, 3 professors. So we can't do this without everybody on the team. And the key really is our seismic monitoring team, which is a geophysical data analyst. We are a 24/7 network, which means there are at least 2 people on duty at all times to help monitor and locate earthquakes. 24 hours a day, 7 days a week, 365 days a year. And this includes times when we have hurricanes and tropical storms. There is always somebody here, ideally working. So the other thing I want to take away is, while we can't predict earthquakes, part of today is maybe we can help you prepare for them. So let's talk about instrumentation. Puerto Rico Seismic Network, we do run different types of instrumentations. We don't just run traditional seismic stations. We have some, this is a map showing some of our regional instrumentation. We have our seismic stations, which are the triangles that are either white, red, or blue. We have partner seismic stations. So we not only use data from Puerto Rico Seismic Network, but we also use data from USGS partners, our partners in the Dominican Republic, partners in the West Indies Islands, specifically the Seismic Research Center at the University of West Indies. So we use not only our data, but other data that comes in. We also have the gray dots, which are the Puerto Rico accelerometers, some of which are run by the Puerto Rico Strong Motion Program, which is our sibling network here at the University of Puerto Rico, Mayagüez. But you might notice that you have 2 other symbols here. One is the diamonds, and the other one are the pentagons. And we also run both sea level gauges as well as GNSS or GPS stations on the islands. So in reality is the Puerto Rico Seismic Network, we are more of a plate boundary observatory than we are as a seismic network. The other thing to note is because of our partnerships with other regional networks in the region, we are in real time, we get a little over 200 seismic stations coming into our system to locate events as they occur. So it's a very important thing to note in the Caribbean is that we all have to work together as islands to create a good seismic network and monitoring for the region. So the other thing I want to note, I just mentioned our partners, is Puerto Rico Seismic Network is part of what's called the Advanced National Seismic System. What is the Advanced National Seismic System? It's a partnership between the federal, the United States Geological Survey, and regional real-time earthquake monitoring systems to provide rapid and reliable information to emergency responders. So what does that mean in terms of Puerto Rico Seismic Network? It means that the PRSN, we provide data, some real-time seismic data from our network, but we also provide the location and magnitude of our located earthquakes to the USGS, and that will be the authoritative solution in the USGS ComCat catalog. So when you go to the USGS webpage, if you see an earthquake in that gray box that I showed a few slides ago in the Puerto Rico and Virgin Islands region, more than likely you're looking at a solution that was located here at the University of Puerto Rico Mayagüez and then contributed to that catalog. So let's talk about earthquakes and how our general seismicity in Puerto Rico. This is a bar graph showing the number of earthquakes per year. The blue bars are magnitude 3.5 or greater. The red is essentially all earthquakes. You might notice that there are some changes through time. That doesn't mean more earthquakes are occurring. Specifically, if you're looking at after 2005, where you see this increase. What you actually are seeing are changes in our networks as we improve. We add more instrumentation, we change our systems, our technology gets better. You have to remember, we started back in 1986, earthquakes were recorded and they had analog recorders on physical paper drums. And then you start the digital revolution and computers, and all of that is contributed to us being able to do our job better. Technology and instrumentation changes. Now, you might also notice a couple dips, like such in 2010, that was station damage due to a hurricane. You have Irma and Maria in 2017. And I did not put 2020 and 2021 on this because this would swamp the graph completely, given if you look at the bar, we have about 5,000. And then if you go to 2020 and 2021, you're talking about over 20,000 earthquakes. So I did not include that in this figure. But really what you're seeing is you can see the improvements of our network through time. And you can see more smaller earthquakes. So what does this mean as far as earthquakes in Puerto Rico? Now, if you think about somewhere that's seismically active, most people say 9 times out of 10 if they're from the United States, oh, Southern California, they're the most active. I'm going to show you a graph and an image here that might argue that we in Puerto Rico and the Virgin Islands are more active than Southern California. So this is why I call this lies, lies, and statistics. So you have the Southern California, which incorporates Los Angeles, the classic San Andreas faults that everyone thinks about when they think about the big one. And what I've done, I've taken about 10 years of data. We have earthquakes at magnitude greater than or equal to a 3.5. I chose that because that is a good completeness value for both networks, because PRSN, because most of our earthquakes occur offshore. It means that we can't see these micro earthquakes that are less than magnitude 1 in our region easily. Whereas California, the earthquakes are onshore, so they can surround it by instruments and see these very, very small earthquakes. And the other reason I chose 3.5, that is what Puerto Rico Seismic Network considers a significant event. So with this, you can see that in general, the orange bars, which is the Puerto Rico Seismic Network, has a larger number than the Southern California network. The exception of this occurs in 2019. And 2019 is when you had the Ridgecrest earthquake in California. So what you're seeing there is the impact of the sequence. Similarly, in 2020 and 2021, you see the impact of the Southwest Puerto Rico seismic sequence in the PRSN bars, where they're much higher than normal. So looking at this, you would see that on average, though, if we look before the sequences, you can see on average, the Puerto Rico Virgin Islands region has more magnitude 3.5 or greater per year than Southern California. The source of my data for this was the PRSN catalog and the Southern California Seismic Network catalog individually. So it's an interesting idea to think that we are more active than Southern California, but yet we aren't the ones that people think about. So if I want to go back and like look at our seismicity, this is essentially what I've done is I made a few heat maps and said I took about 10 years of data here. I probably should make these maps at this point. And all I did was grid it up in a simple hit count in each box. And we see where you have the hotter colors is where we have more activity. You might notice as far as our hotspots, you have some activity in the Anegada Passage, southwestern Puerto Rico, and then along the north and along our trench or the trench region. Now, if you look at our shallow seismicity, you can see that the shallow seismicity, again, you highlight, there should be earthquakes less than 40 kilometers here, you highlight southern Puerto Rico, as well as a bit in the Anegada Passage. And again, you still have some activity of crustal deformation due to the subduction. However, if you look at earthquake greater than 40 kilometers, you can see that's all limited to the north, and that's because that is where the subducted slab is located. So what is this activity? Well, this is actually from one of our master students, formerly from the networks, Francisco. He now works at the Strong Motion program. What he did was look at swarm activity, specifically in the north. And there are different regions that have earthquake swarms. And earthquake swarms are endemic in the Puerto Rico Seismic Network catalog. So this is something that we commonly see even on our monthly reports. You'll see a list of swarms and sequences. Now, what is a swarm? A swarm activity is when you have, this is an example of a Mona Passage swarm, which is to the west of Puerto Rico. And what you notice is you have activity pick up, number of earthquakes at times. Each one of these dots is a single earthquake and then it goes away. But you don't have a single large earthquake to kick off the energy. Compare that to a sequence. This is the same region, Mona Passage. You have an earthquake of about 4.2. Then after that 4.2, you have a spurt of activity as it then dies down back into what we call background seismicity. And then you can have multiple sequences at once. This is the Sombrero, which is a bit to the northeast side. And you have a bunch of different sequences occur right after each other. So sequence and relax, sequence and another, and then sequence and another. So they add up on each other. But swarm activity, we're talking there is no significant single large event. And this is endemic in our region. Most of these last for a few days. Does give our analysts a bit of a headache because there's a large amount of work to locate a significant number of earthquakes, but we don't have as one significant event. This is from the activity from the north, but they do occur in other regions. We do have some swarms that does occur in the south as well. So I've talked about earthquakes and some of the general seismicity in Puerto Rico and the Virgin Islands. But the question is for you as a viewer is, where do I find information? Because Puerto Rico Seismic Network, the Virgin Islands are part of our area of responsibility, we do provide that information in English. All of our staff here are bilingual in Spanish and English, so if you ever have questions, yes, you can call us. But you can find that information on our webpage. You have it'd be redsismica.uprm.edu. Now, if you look at this, you'll see when we enter, this might have a top header. If it's in Spanish, you'll have up in the upper right, there'll be English/Ingles, and you'll be able to switch it to the English version. These are now mirrored sites, so you should have exactly the same information in English as you do in Spanish. The other thing is we do have a Twitter, is twitter.com/redsismica, and you can also follow us on Facebook. On those posts, some of them are in Spanish, some of them are in English. We do try to put out in both languages at this point, though. So if there's people want more in English, please let us know. So what you might see is information. Let's say you felt a significant event. you might notice that we have a banner at the top of our page. Now, if there's a significant event, we will change this banner to have that information immediately there, and you should be able to click on that to get more information. And in Puerto Rico, if there's a tsunami watch advisory information statement, the lighthouse will emit a light, either green, yellow, orange, or red, depending on the level of tsunami alert in Puerto Rico. Note I'm saying Puerto Rico here, not the Virgin Islands, because Puerto Rico Seismic Network is tsunami warning focal point alternate for Puerto Rico. Albeit I think the information will be very similar for Virgin Islands as well. And further down the page, you'll also see a list of earthquakes. You can choose either the latest significant events, which will have anything that is felt, that's been reported as felt, anything that's greater than magnitude 3.5, or has a tsunami information statement attached to it, or greater attached to it. And then you also have latest earthquakes. It would be all the smaller magnitude events, things that would be like the 1s, the 2s, that have not been reported as felt. So it does not have to be a significant event of magnitude 3.5 or greater. It can be a felt event that we've had felt events in Southwest Puerto Rico of less on a magnitude of like 1.7, 1.8. People have felt those events in Southwest Puerto Rico. And so those have been reported to us as felt, but it's not a significant magnitude. So that's where you basically would be able to find our first set of information. Now let's talk about felt events a little bit more. In Puerto Rico Seismic Network, we do not know if an event was felt in the Virgin Islands unless you tell us. And reality is we need your data. You saw Roy, my colleague, talk a bit earlier about the modified Mercalli scale. In order for us to generate that information for a felt event, we need the information from the public. And so if you go to the information on any particular event, I chose this event, which was felt in the Virgin Islands. I think it was a couple nights ago, about 11 p.m. It was a 3.8 magnitude event. And if you go to the general information on that event, you should have a button on the top right that says, did you feel it? Report it. You click on that, and it'll take you to the form here on the right. And you can fill out that form and provide us at the Puerto Rico Seismic Network the information. So one, we know it was a felt event in Virgin Islands. And secondly, we have your data to be able to assess the amount of shaking. And this is also very useful for emergency management in the Virgin Islands, because then that might be able to help them focus resources if they have a more precise and accurate, did you feel it map based off of your user data. So let's say you go in, felt an event, but it's not up on our webpage yet. It might have been, this could occur if it was a small magnitude event. Let's say it was a magnitude 2 that was felt. That's going to be just in our general processing queue. So it might not be on our front webpage yet. In which case, you can go into our webpage and go Earthquake Tsunami Seismicity portal. Here you can find information on our catalogs, but yeah, on one of these circles on the bottom, you'll see reported felt earthquake. And you can click on that and you can fill out a form with the time and where you felt the earthquake, and we'll be able to check our instrumentations and process the event as a felt event. So that would be how you actually report a felt event to the Puerto Rico Seismic Network. And I will stress again that this is critical for us as a service provider for the Virgin Islands. So I'm going to go into a little bit of a sidebar here. One question that always comes up is, why did I feel this event so strongly, or why didn't I feel it? Well, why do you feel the event so much or so little shaking depends on different factors. It depends on things like the earthquake magnitude, how much energy is put out, the earthquake location relative to where you are. Is it a shallow earthquake right beneath your house, or is it 100+ kilometers depth and 200 kilometers away? And it's also the earthquake focal mechanism. So what type of fault is it? Because a fault is not like an explosion that puts out energy equally. It can put out energy with a directionality. And this is what the focal mechanism might do. It might shoot here, especially for the normal events in Southwest Puerto Rico, it'll shoot most of the energy towards the north. And so someone going to the north might feel it more than someone that is along one of the nodal planes. The other things that might influence it is the type of building. Are you in a one-floor building, or are you on the top of a high-rise? If you're at the top of a high-rise, you're definitely going to feel it more than that person on the one-story building. And then critically, the type of soil you have built on, that ground beneath you. And ground beneath you is critical in Puerto Rico and the Virgin Islands, because something called amplification. And so I was going to show you an example of amplification in the next slide. What amplification is when you have a soft soil above hard rock. Essentially, think about as energy is traveling and it goes from a fast hard rock into a slow soil. And essentially what that'll cause is a traffic jam of energy. The energy can't back up into the hard rock. So what it does is it piles up on top of each other and makes a larger amplitude wave, which would then make more shaking. So that would be what we call amplification. And in Puerto Rico and the Virgin Islands, we have amplification not only due to soil types, but also due to topographic impacts. So as an example of this is amplification in Puerto Rico. The two purple sites, right here you have the waveforms, and here's the map of Puerto Rico. This is Mayagüez and Almagueras along the central west coast. You have two stations, so which are called core and HMR1, and those are on bedrock. Versus you have the red stations, BIAL, which is on a biology building in UPR on campus, and MYO3. Both of these are on soil. And what you might notice is the waveforms, these are all the same y-axis. The waveforms at the soil sites are significantly larger, which means there's more shaking at those sites, more peak ground accelerations. And this is why soil type is important, because compared to bedrock, the soils actually have generated much more shaking. And to give you a scale, to get from about the core to the biology building, you're talking on the order of a few miles, talking about 5 miles at most. So this is along a very short scale. So when short, wherever you build in the Virgin Islands of Puerto Rico, you really need to do a site study so you know what you're building on and you can build appropriately. So I'm going to spend the last few minutes to talk about some other resources. The PRSN, I did mention before, we have an entire education and outreach staff. They do exist. There's also some online educational resources. And you can fill out a form online and request courses from PRSN. If you want to know more about what we do and things and about earthquakes in the region, I encourage you to fill out the form and request a virtual talk. Obviously, we can't fly to the Virgin Islands, but we can do virtual talks. So we do have an earthquake education portal. It is now in English as well. So it is in English and Spanish, and it has general information about earthquakes. So if you want to know more about the information that Roy and myself presented, I encourage you to go look at our earthquake portal there. I'll say for the Puerto Rico National Tsunami Hazard Mitigation Program, we have developed a tsunami education website. It is in Spanish and English. However, note that it is focused on Puerto Rico and the Puerto Rico Tsunami Program, but it also is a resource you can use to find out about general information on some tsunamis, especially with the course one that's just on general tsunamis. The maps, etc., is focused on Puerto Rico and the Puerto Rico Tsunami Program, but it might have some useful resources for you as a user. And then also, if you want to request a conference, you go on earthquakes and tsunamis, and you can go conference request and then fill out the form and request the conference. We do not do conferences by email. You have to fill out the form, and then it can be scheduled given the availability of our education staff. Our education staff are 2 people plus 1 person of the tsunami program, as well as students who do work at the network. I also want to mention that we are an investigation. I'm a research professor. Dr. Victor Ruffin, our director, is a research professor. And we also have Alberto Lopez, who works on our GNSS. So we do have 3 professors in UPRM geology, and we work on things from seismology and tectonics, network operations, tsunamis, and earthquake hazards. And we do also collaborate well with our civil engineering partners at the Puerto Rico Strong Motion Program. And here I just have some examples from research. You can see me in the field with one of our partners from Summer Field Hands and our partner, one of my colleagues from USGS. And I can here, if you want to see, they had this movie of the fault plane of the 6.4 of 2120, as well as some of the events before the 2020 6.4 on this bottom picture, and then new crustal ground motion prediction equations that were developed by my recent PhD student, Diego Carlos. So these are the types of things that we are working on at PRSN. We do also work on tsunamis and GNSS. So if someone's looking, we are always happy to talk about our research as well. And here, because we're talking about shakeout, this is just a reminder, is in Puerto Rico and the Virgin Islands, we all celebrate shakeout on the same time. So it's going to be October 20th in 2022 at 10 a.m. And really is a drop, cover, and hold on. And I want to end by showing you an example of why one should drop, cover, and hold on. This is from the 2020 earthquake sequence. And this is a school in Southwest Puerto Rico. And what you've noticed that the school itself has collapsed, essentially done a pancake collapse. However, if you look inside the school, what you notice in the bottom right is if the students had drop cover and held on beneath their desks, if forbid it was actually populated at the time, thankfully there was no school at the time, that it would have been survivable if people dropped cover and held on, but if they had left, they might have been hit on the head by concrete that had fallen in or other debris. So this is pictures from Fernando Martinez, who was a graduate student here at UPR in geology. I think he's now working in FEMA. But these are pictures that are from him of the school in Southwest Puerto Rico. And this is why practicing drop, cover, and hold on is so critical and why everybody in Puerto Rico and Virgin Islands should participate on Shakeout. And I do want to add, I want to thank everyone here now and say, really in geology and geophysics, you have the saying that the present is the key to the past by Charles Lyell and the Principles of Geology. But however, for earthquake tsunami hazard, arguably the past and learning from the past is the key to the present and future and preventing disaster and disaster when you do have a significant earthquake in the region. Because it's not if, it is when. Thank you.
Thank you very much, Dr. Van Coor, and I hope all of the viewers were able to learn a lot of key information from the PRSN. And as she mentioned, there are many resources that will be available, so please feel free to log in and share them. Now I will proceed to our next speaker, which is Ms. Allison Shumway. Ms. Shumway is a research geophysicist with expertise in probabilistic seismic hazard analysis. She earned her bachelor's degree in geological sciences from the State University of New York College at Geneseo and her master's degree in earth sciences from the University of Memphis. She began her professional career in Colorado working as a geologist for a geo-consulting firm before transitioning into the area of PSHA, which is the probabilistic seismic hazard analysis. She has worked on many PSHA site-specific nuclear power plant projects across the U.S. and was involved in the central and eastern U.S. seismic source characterization for nuclear facilities project. In 2015, she accepted a position with the U.S. Geological Survey in Golden, Colorado, working in the National Seismic Hazard Model Project, which develops earthquake hazard models and maps for the conterminous U.S., Alaska, Hawaii, and the U.S. territories. These maps forecast how much the ground could shake from an earthquake and are used by the building code community. Buildings, which include buildings, bridges, highways, and railways, and can include many other areas. Risk modelers, and to inform public policy decisions. She is the project lead of the 2025 Puerto Rico and U.S. Virgin Islands National Seismic Hazard Model Update. I'll turn it over to you, Ms. Shumway, for your presentation.
Thank you, Regina, for that introduction. And also thank you to the organizers as well as Regina for organizing this great workshop and for inviting me to talk today on behalf of the USGS. So as Regina mentioned, I am a research geophysicist at the USGS. And today I'm going to be talking about the update of the Puerto Rico and U.S. Virgin Islands National Seismic Hazard Model. And I am representing the National Seismic Hazard Model Project and our colleagues. So just a little bit of background, the National Seismic Hazard Model Project, or the NSHMP, develops seismic hazard models for the conterminous U.S., Alaska, Hawaii, and the U.S. territories. So of course, this includes Puerto Rico and the U.S. Virgin Islands. The National Seismic Hazard Models forecast where and how ground shaking could occur from an earthquake. These models and related products, which include the seismic hazard maps, scenarios, and risk assessments, are used to inform building codes and other structures, insurance, and public policies. The original PRVI NSHM was released in 2003, so it's almost 20 years out of date. Since then, lots of new data, methods, and models have been released. And Congress has recently provided funds to the USGS Earthquake Hazards Program to accelerate this update. So we've just started it and we plan to update the PRVI NSHM in 2025. So what is a seismic hazard model or map? First, I have to greatly thank my two colleagues that have preceded me that gave you a lot of information about earthquakes, because earthquakes are what go into this map. This map basically shows how much the ground could shake from an earthquake. It's one of the flagship products of the USGS Earthquake Hazards Program, And many different areas of research and different scientists work on these, and we consider it a community model. As we're developing the models, no matter if it's the conterminous US or Puerto Rico and the US Virgin Islands, we welcome data and methods and input from scientists from the scientific community, and we really want this to be a community model that everyone can buy into and use. So what is a seismic hazard assessment? As my colleagues before me have talked about, earthquakes are the main input into the seismic hazard model because earthquakes are what cause the ground shaking. So basically what we're doing is we're trying to model where earthquakes will occur and the different parameters that happen, because as my colleagues have mentioned before, earthquakes occur at different places, and there is either plate shifting back and forth or subducting, and different parameters cause these earthquakes. And sometimes we know where the faults are, sometimes we do not, but there's seismicity there. So there's different ways that we can model how the earthquake is going to occur. The next main input is the ground motion model, or how the ground is going to shake. And in many areas, we'll have a lot of data provided from local earthquakes where we can make these models, but normally, because the record of earthquakes is not very long, we will use earthquakes from around the world to help us inform these models. And then you take the earthquake source, the way the ground can shake, and then that's how you actually, those are the inputs into the probable seismic hazard calculation, which gets a little bit technical, but basically what you want to do is it's going to forecast how much the ground could shake at a certain time. So that produces this hazard curve. And then what the engineers or other users would want to know is how likely is the ground to shake in a certain time period. So what you can do is basically pick off that time period on this curve, and that gives you 1 point, which you can put on a map. And the maps that we make are just a bunch of the points off of the different hazard curves that end up producing this map for engineers or others who want to use the model. So why are they important and who uses them? Well, I think we've heard a lot today about why studying these earthquakes are so important and why the hazard maps can be very useful to many different organizations. So there's many international organizations that use our products that we work with, many government organizations, including FEMA and also FERC, who's currently doing a study in Puerto Rico, that have been talking to us about seismic hazard models, but also, as we mentioned, insurance, building codes, and risk modelers are all interested in earthquake hazard risk, so they can use this to plan better resources. So as I mentioned, the original PRVI National Seismic Hazard Model was last done in 2003. You can find the documentation as an open file report online, and there's also an earthquake spectra paper available. So back in 2003, the earthquake source model that was used, we used 4 global seismicity catalogs to inform the study, but we unfortunately did not use any data from the Puerto Rico seismic network. One crustal onshore fault, the South Lajas fault, was used, and then a bunch of offshore faults and some other faults in the area. The ground shaking models that were used were very old models. They're 20 years old now. They don't use the current new generation attenuation ground motion models or shaking models that we have available, and only one of those shaking models was actually developed specifically for the area. The products that were developed at the time, there's an example on the right-hand side of one of these seismic hazard maps that were developed. We only developed it for a couple of periods, peak ground acceleration on the top, 1 second and 0.2 seconds, and we only did this for a couple of return periods. But all of this data can be found on the science-based site listed below if you'd like to check out the current seismic hazard maps that we have available for Puerto Rico and the US Virgin Islands. So this is a different version of the map that my other 2 colleagues have showed previously, and this is just to reiterate that we all know now that Puerto Rico and the US Virgin Islands are in a very complex tectonic setting, and all of this information is used to inform the model and forecast where earthquakes will happen in the future. So we're planning for the 2025 PRVI source model update. Like I talked about, there's 2 different inputs. The source model, where the earthquakes are actually occurring. So we're currently working with our colleagues at the University of Puerto Rico Mayagüez to study the different faults on Puerto Rico offshore and around the US Virgin Islands. So in this upper right-hand corner, this is a Puerto Rico fault map of the current mapped faults and different ones that we're considering to add into the model. As Dr. Vanacore mentioned, there's lots of different faults available, but for the seismic hazard model, it's very important to know how likely the fault is to produce an earthquake. Sometimes we know that information, sometimes we don't. So even though there's a fault there, it might not necessarily end up in the model a particular way. It could be modeled as a fault zone, which Dr. Vanacore also mentioned, versus just an actual fault. So we're currently working with our colleagues there to model to see what different faults are going to be used. I mentioned in 2003, we actually only had one fault that was in our model, but this time we're looking at 5 or 6 new different faults onshore Puerto Rico that will be added to the model. We're also very excited to use the seismicity data from the Puerto Rico Seismic Network. We just heard from Dr. Vanacore, and I mentioned we didn't use that data last time around. So now we have tons and tons of data provided from them and all of their hard work that will be used in this update of this model. There's also going to be new geodetic information. So basically the information that's used of how the Earth is changing up or down will go into this. And then these are just a few more images of the faults along Puerto Rico that our geologists are currently out in the field taking measurements and getting data to use for this input model. The second component, again, is how the ground shakes. So again, we are currently working with our colleagues at the University of Puerto Rico Mayagüez, and we have people out in the field that are looking at strong ground motion. So we'll have a Puerto Rico strong motion data set to use. And I mentioned the ground shaking models were very old last time around. Now we have the new generation attenuation NGA West ground motion models that are used for crustal earthquakes. There's also an NGA subduction ground motion models that are used for subduction earthquakes. And we also hope to use some Puerto Rico specific ground motion models. So all of that will help advance the model. The other thing we're looking at is new VS30 data and site response. Like Dr. Vanacore mentioned, it depends what type of rock or soil you're sitting on. So we're taking different measurements of that across Puerto Rico and the US Virgin Islands to help inform the model. The products that we're hoping to release, I mentioned before in 2003, we released results for PGA and a few different spectral periods. This time around, we hope to release results for 21 spectral periods, including PGA, PGV, and a whole bunch of different site conditions. So whether or not you're seeing on rock or seeing on a soil, and then depending on what type of return period you want. And this is important because the users, the building codes, need different spectral periods. Depending on how the ground shakes, you can have high frequency shaking, a low period that affects certain buildings, and then you could have longer periods that affect structures like bridges and things like that. So having this spectrum of a broader range of spectral periods instead of just 3 is super important to our building code partners. So we're happy to be able to produce this in the next round of the maps. On the right-hand side, I'm showing, and there's a link to a website, the NSHM hazard tool. So as we develop this model, you'll be able to go to this hazard tool and play around with some of these different functions. You can spit out hazard curves. You can look at ground shaking models versus distance, ground shaking versus magnitude. You'll also be able to do some disaggregations. So these are a fun study of, you can pick one point, do a disaggregation, and it will tell you the different sources that are contributing to hazard. So whether or not it's a fault that's really close by you or it's a faraway subduction zone, it'll break down the different ways that different sources that are causing hazard related to you. Super important to our building code engineers because we basically say, we put some estimates on our bounds. So there's an uncertainty either way of the estimates that we produce. We'll produce scenarios and risk assessments. The one thing that was interesting in 2003, we did not produce any scenarios based on that estimate. And I think those are going to be very beneficial to emergency managers. So basically, you could take the event that happened in 1867, and you could produce a scenario that would be very similar to an earthquake of that size, that distance, the parameters that happened at the time, and we can make a forecast for you of how the ground would shake in different areas, and then the emergency management planners could use that to help plan the different areas that they would want to respond and what type of buildings are sitting there. But we also want to hear from you and what products will be most useful for you. I showed you seismic hazard maps, which show ground shaking, but sometimes that's not very intuitive. One of my colleagues today talked about the MMI scale, which tends to be more intuitive for the general public, if they just want to know the intensity of how the ground is shaking. So we can produce MMI maps, which may be more beneficial to the general public to understand their risk of hazard. On our website currently, there's a timeline for those that are more interested in the update. Right now, we are, as I mentioned, currently collecting data, and that data will be collected by the end of this calendar year, and then we'll be working on the draft model next year into early 2024. There'll be chances for feedback from the public. We'll be having public workshops that anyone is available to attend, and they can hear about the science and give us some feedback. And then we plan to have the model done at the end of 2024 and published in 2025. So just to conclude, we'll be releasing the model in 2025. It'll be based on the best available science. And a lot of these updates are dependent on the local expertise in the area. And we want your input into the development and the rollout of the process. If there's certain products that you'd like to see that would be useful for you, that we would really like to know about it. So on this right-hand side, I've put the link to our website where you can go hear about workshops. There's also a link on that website where you can subscribe to our newsletter. So you'll be able to hear about upcoming workshops and hear about products. And you can always email me at the address here, or if you have general questions about the NSHP products that we have, you can email this address here. Thank you so much.
Thank you very much, Allison, for that informative presentation on USGS. I hope that as all the viewers are actually watching the presentations, they're learning a lot, because it's a lot of different partners that we work with, and a lot of resources are available to all of the viewers in the Caribbean. Now I'm going to proceed to one of our sister islands, which is Director Penn of the British Virgin Islands. I'll present his information and his biography, and then I'll turn it over to him as well. Director Jason Penn was appointed to be the lead of the Department of Disaster Management in 2021. Mr. Penn first joined the Department of Disaster Management in 1999 as an employee and volunteered with them from 1994. He has over 23 years of experience working in the area of emergency management and disaster emergency communications. He holds a master's certificate in development and public investment project management from the University of Laval, Canada, an executive diploma in management from the Chartered Managers Institute in the United Kingdom. Mr. Penn is recognized as an associate emergency manager by the International Association of Emergency Managers and has received a long service award from the Caribbean Disaster Emergency Management Agency. Mr. Penn is one of the co-chairmen of the Intergovernmental Coordination Group for the Tsunami and Other Coastal Hazards Warning System for the Caribbean and adjacent regions. He's also a licensed amateur radio operator holding a general license. I will turn it over to Director Penn for his presentation at this time.
Thank you for that introduction, Ms. Brown, and good morning to everyone that's listening. As you rightfully mentioned, I've been with the Department of Disaster Management here in the British Virgin Islands for some time, and I have been working very closely with the colleagues at the Puerto Rico Seismic Network, Puerto Rico Strong Motion Program, as well as the Caribbean Tsunami Warning Program. So what I'm going to give today is an overview in terms of the seismic instrumentation, as well as the works that has been done over here in the British Virgin Islands with my colleagues within the field of seismicity. In terms of the British Virgin Islands, located 60 miles east of Puerto Rico, our last census indicated that we have a population of about 28,000. From the map, quite a few islands, 50 islands and keys. This is one of the better maps, as it sort of highlights the keys as well as the larger major islands as well. All the islands are of volcanic origin except for Anegada, which is made of coral limestone, and it's very, very flat. The highest point on Anegada is only 28 feet above sea level and is located about 30 miles northeast of the remaining islands. Now, in terms of a history of interacting with the Puerto Rico Seismic Network, in 1999, a team visited the BVI and forging a relationship in terms of seismic monitoring as well as research. And that would have been what sort of started a relationship with the University of Puerto Rico in Mayagüez. The image you're seeing here is one of myself, my former director, as well as the team led by Christoph Van Hillebrand at the time that came across, and we had that first initial meeting. The other image is what would be the location of the first seismic station in the British Virgin Islands, where to this day that particular station is still one of the main sites. So what did this relationship or partnership help to do for the British Virgin Islands? Well, a MOU was signed in 1999, and since that time, as I highlighted, we had our first seismic station, which was installed around that time as well. Through that relationship with the Puerto Rico Seismic Network, it also created a partnership with the Puerto Rico Strong Motion Program in 2005, which I would speak more of as I move further into the presentation. It also offers us means of training in terms of the seismic monitoring equipment. Those teams have been here quite a few times and have provided training to the local staff. We've also had training in both seismic and tide gauge stations, which that also was provided by the Puerto Rico Seismic Network, where we've actually visited Puerto Rico and took part in a lot of the training that they've had over there. And what this partnership has also created is allow more partners to develop, where we're now partnering with UNAFCO, USGS, as well as the as well as the Pacific Tsunami Warning Center. Now, with the Puerto Rico Seismic Network, what has been done so far for over the years that we've been in collaboration, we've had 2 seismic stations installed. The picture here, as you can see, was the picture of previously, the image you saw previously is about 21 or 20 something years old. This is how the current day seismic station would have looked. The image to the bottom is where you would have the team from USGS as well as PRSN and UNFCO. They were installing and building the second seismic station. So what that did for us, there's a seismic station located in Ojangata. There's also one in Anegada, and there's a backup in Rotown. And what we also get from this partnership from Puerto Rico Seismic Network, as would have been highlighted by Dr. Elizabeth, is they do provide monitoring for the British Virgin Islands as well because of the MOU and the relationship that we've developed. And whenever watches or warnings or any type of seismic information in terms of earthquake is produced, is usually received by the British Virgin Islands as well. What we also do from them by learning from them is that we also monitor the instrumentation as well as we provide minor maintenance to the instrumentation for the Puerto Rico Seismic Network. What we also get as well is access to their expertise in terms of seismology and tsunami hazards. If there's anything that we need clarification on, or if there's any particular educational outreach that we see the need to have their input, when we reach out, our persons are always available and very willing to provide that type of information to us as well. And I've continued to mention, and I would, training opportunities across multiple agencies. We've received a host of training from the PRSN in terms of seismology and earthquakes. In continuation of the Puerto Rico Seismic Network, what they've provided and assisted us with as well, they've assisted in getting us satellite IDs for our tide gauges. I'm switching gears a bit to in terms of tidal stations. They have been very instrumental in helping us in this regard. In terms of repair and providing parts, we've received a number of parts from them as well as repairs. Once they visit the territory, the technicians usually help us to make repairs that we cannot do on our own. They've also assisted in training the technicians that we have in being able to do minor maintenance and minor upkeep of the tide gauges. What this relationship with the Puerto Rico Seismic Network has also helped us to achieve. It's creating avenues for us to be a part of the UNESCO IOC, thus where the BVI would have been involved at the ICG Caribbean wave level. That again was something through our relationship with the Puerto Rico Seismic Network. In addition to when we were trying to purchase or source tide gauges, we reached out to them as well, who provided the expertise in terms of what type of gauges we would need to purchase. And once that information was shared, we went ahead and we purchased 2 additional systems. Now, in terms of tsunami monitoring, again, our relationship with the Puerto Rico Seismic Network did allow us to take part in the tsunami ready recognition program. I have two symbols up here because the first time that we took part, it was under the National Weather Service project program, which we were successful. I think we were the second English-speaking Caribbean country outside of Anguilla and outside of the U.S. to achieve tsunami ready recognition. We would have recently gone through a recognition process in 2021, which we were successful. Likewise, as I mentioned again, this relationship allowed us to be invited to our first meeting in Martinique in 2009. I would have mentioned before when I was speaking, where we were able to receive watches and warnings in conjunction with the United States, Virgin Islands, and Puerto Rico. Why this is very important is that under the ICG Caribbean EWS, even though that the Pacific Tsunami Warning Center provides information to the other countries, which would have to make the decision whether to issue watches or warnings. Our relationship allows us that once watches or warnings are issued for Puerto Rico or the U.S. Virgin Islands, it's also done for us as well. In terms of further assistance that we received from them, when we were developing or trying to achieve the tsunami ready recognition, quite a bit of time and assistance was provided through PRSN in the designing or even fulfilling of our maps, correction of our protocols, development of our standard operating procedures. That was also done as well. Access to the IOC sea level databases, where the information from our tide gauge usually would go to this particular database, which was a godsend for us because when we suffered extreme damage during Irma, we were able to retrieve, once we were able to get back internet access, we were able to retrieve a lot of that data that was needed for other purposes. In terms of us, again, I mentioned the Virgin Islands, us being able to serve on the different committees such as Tsunami Ready, even the opportunity for me to be one of the co-chairs for the English-speaking Caribbean. This wouldn't have been possible again without the relationships that we've shared with the PRSN over those many years, as well as the Caribbean Tsunami Warning Program. Now, I'll just switch a bit to the Puerto Rico Strong Motion Program, and I would also give credit to Dr. Jose Martinez Cruzado, as a number of the slides I would be sharing directly taken from him that he so obliged and allowed me to use. So I do give him credit for the slides that I would be presenting as I move forward in this part of the presentation. But the first engagement that we had with the Puerto Rico Strong Motion Program, again, was in 2005. And you could have seen this is their goal, obviously, was to identify and characterize the ground response as well as the civil infrastructure response upon seismic loads, and to provide reliable strong motion data to the academic community to enhance the regulations of construction codes. So one of the criteria that when we first met with Dr. Martinez and Dr. Martinez Cruzado and his team is he pointed out that the reason for selection of some of the sites, again, was the proximity to the regions of high seismicity, the high populated areas, the site geology, the instrument security, as well as being able to have good access to maintenance. And from this slide, you could see that his team, in conjunction with us, there was a lot of work that was put into the British Virgin Islands in terms of instrumentation for strong motion sensors. You'd have see I don't know if I have a pointer, but you would see here in our government admin building, they would have put sensors here. This again is a different type of soil type. Most of this land is reclaimed land. It's pretty much filled over the last 40 to 50 years. So it's more or less sand that was dredged and filled in for quite a bit of time. This particular site over here, disaster management, which is also close to this location, both are within the capital of Road Town, but they're located on different soil types. We see here instrumentation was also done at Beef Island for our control tower. We moved to one of another islands, our sister islands of Virgin Islands, which is the second most heavily populated island, and instrumentation was done there as well. So in all, the team of PRSMP did quite a bit in terms of instrumentation with strong motion sensors throughout the British Virgin Islands. And some of the data that was recorded on 18/14/2006, that was actually the first recording that came from one of the strong motion sensors, and you can see the magnitude came in at 5.5.0. And this particular image represents where the epicenter of that event was felt. So it was good to see that with the installations that he was able to share data with us in terms of what had happened, the magnitude of the particular quake. Now, a lot of work has been done in terms of not just the instrumentation around the island, but as well as instrumentation within some of the two of the buildings. But I'll focus more so on the control tower, just to give you an example again what the partnerships have actually done for the British Virgin Islands. So these models again came from him. These are just the stills, but I remember seeing the presentation a few years ago where he actually had the actual 3D model. So what they did was, with the instrumentation of the particular control tower, they placed sensors, I think, to the top, to the center, and to the bottom in the basement of the building. The government was able to share the plans with the team, who then took those plans and designed a model that replicated the actual control tower. Now, the good thing is, when that model was done, and when Dr. Martinez, I think he was invited and he did a presentation at a safer building workshop that we had here, he was able to take data and use this particular model and sample, and to show the engineers and the architects and even the construction personnel that were at this workshop how the actual control tower moved when being affected by certain magnitude earthquakes. And I think they were even to model to the point where they could have, based on not just data that they had collected, but to be able to provide an idea of particularly what type of shaking or level of shaking it would take to actually damaged that structure. And I thought that was pretty interesting. A lot of work went into this. I think that the persons in attendance as well were very appreciative, because it showed that for the instrumentation and the different areas, that the different locations where they have these sensors, it actually showed the public that, the data being collected is of sound and it can be used for the greater good of the Virgin Islands. So I thought I would just share. This is just one cross section of the work that's being done by the Puerto Rico Strong Motion program here in the Virgin Islands, as well as the many interviews that they give every time they arrive, educating the public to why they are visiting and what works are going to be completed upon their visit here to the territory. Now, I also wanted to highlight this as well, because this is a next section of work that was being done by the Strong Motion program, of where they actually developed a real-time database that connected all of the sensors in the field back to our department, and allowed us to see the live streams in real time. And we were able to see when if there were particular earthquakes or any type of shocks. You would see here in the photo, this was Dr. Hueta, who also traveled with the team at some point, that was dealing with the programming along with his assistant, tying everything together, creating the maps, and ensuring that the streams and everything else worked properly. And this particular system, they also had it mirrored back at the Strong Motion program. So they were seeing exactly what we are seeing here in the territory. Just to backtrack a bit, the Puerto Rico Seismic Network also had within our department a similar setup that was tied to a backup sensor that allows us to see the streams from that sensor, and they too could have monitored that real time as well back in their offices. So between the PRS and the PRSMP, a lot of work went into getting us thus far, and even getting to the point where we were now able to connect a lot of the instrumentation that was in the field and now bring it in house and be able to display to the public, even when we've had several field trips from students, to be able to explain and show them these particular graphs and educate them a little bit more in terms of not just from the earthquake standpoint, but be able to see and understand what the different data streams meant. Sorry. Now, with everything that I spoke about and highlighted before, when it came to the hurricanes Irma and Maria, the time that we spent building and putting a lot of these systems together, a lot of that was destroyed. And it did leave us in a peculiar spot for some time. Just some of the images I have here, you would have, this is the elevator shaft where you'll have thousands of dollars of equipment that was damaged. The black boxes that you see there, that's some of the equipment. One of those particular boxes at the time would have been upwards of, I think, within the range of 20 or a little bit over 20 something thousand dollars. So you can see that's almost close to $100,000 in equipment that was damaged. So we did lose quite a bit of the equipment and the systems that were installed over the years through our collaborations. However, despite the setbacks, despite the damages from the hurricanes, a lot of work has happened since then. The images that I'm showing you here, you would see in the top left-hand corner, that would be Dr. Martinez and his team, as well as persons from our organization as well. Irma, right after, I think maybe not too long after Irma, as soon as they allowed for some opening, they came and visited and did some reconnaissance to see what was left, what was salvageable, and what works would have needed to begin taking place. We would have requested and wrote several grants and reports indicating where we try to retrieve or even get funding for a lot of the equipment. I must say that because we are able to show what the relationship provided all those years, and we were able to present to the government the importance of having the seismic instrumentation and having the networks we built. They did answer our call and provided funding to replace most of the equipment that we would have lost from our end. So these are just some of the images to show that the teams have begun working. They have put back in some of the instrumentation. We've been in contact with the teams from the Puerto Rico Seismic Network as well, which has, in terms of the seismic stations, have in their possession a number of these equipment as well, as in speaking to our partners through the USGS, through UNAFCO. There's a collaboration going on and where they're trying to make arrangements to start the process of at least putting back, getting a lot of these systems back online. But as you can see, at least from the photos, we've made some progress. In a number of the instrumentation is back in and is presently collecting data. Now, where we supposed to see the next steps, as I just highlighted that, one of the things that PRSMP has done is to try and move the strong motion sensors to being solar powered. That would have been some of the newer type of strong motion sensors that you've seen. The hope is to have nine strong motion sites completed, hopefully between next year and the following year. In terms of the seismic stations, as I mentioned, we've been in constant contact with the Puerto Rico Seismic Network, and they are making arrangements again to bring those 2 sites back up. We've already made preparations for the backup site. I forgot to mention that our entire building was demolished, destroyed. However, there's a location already prepped to hold a backup seismic station. The installation of new GPSs, again, through the collaboration, with PRSN, their talks with UNAFCO, USGS, and also to provide a team to come in and begin putting the GPSs back in place. And in terms of the tide gauges, we've been in constant talks again with the team from the Puerto Rico Seismic Network to recommission the 1 gauge that was installed previously. We were able to purchase 2, and the PRSN was also able to purchase a gauge, which would, in a sense, give us 4 tide gauges over here in the British Virgin Islands. That's the end of my presentation, but I would just like to say, and I would like to thank, and again, re-emphasize, I'd like to thank Krista Van Hillebrand and her team for the work that she's done. Victor Homfano and his team as well for always being supportive and providing assistance, as well as Dr. Jose Martinez Cruzado, who provided a number of the slides in the ending of my presentation. Him and his team has also done a lot of work here in the British Virgin Islands, and we look forward in the continued partnership with the University of Puerto Rico, the Mayagüez campus, with the whole enchilada of the different entities that I've mentioned there. So I will just close and say that the collaboration and the relationships in terms of the MOU that we signed with these entities have provided a lot of great assistance to the British Virgin Islands. And I thank you.
Thank you very much, Director Penn, for that great presentation. We definitely learned a lot of information from our Puerto Rico partners as well as our BVI partners. Now we're going to hear from one of our tsunami champions who actually works with us day to day. That is Mrs. Krista Van Hillebrand. She was not able to join us today, but she ensured that she recorded her presentation. So that's going to be played right after I read her biography. Ms. Hillebrand is the Deputy Director of the International Tsunami Information Center and manager of its Caribbean office in Mayagüez, Puerto Rico. Krista's work focuses on advancing tsunami preparedness for and resilience to tsunamis in the U.S., the Caribbean, and globally. Krista actively engages in scientific capacity building, outreach, communication, and intergovernmental coordination activities. She holds a Bachelor's of Science in Geology from the University of Delaware and a master's degree in geology, specializing in volcanology from the National Polytechnic School of Quito, Ecuador, where she's actually conducting some studies right now. So now we'll go right into her pre-recorded presentation.
Good morning. My name is Krista von Hillebrand Andrade. The U.S. Virgin Islands is surrounded by faults, near and far, that can generate a tsunami at any moment. In this map, the Virgin Islands is represented by the red star. To the north, we can see the Puerto Rico Trench, which is a source of large earthquakes and potential tsunamis. To the south of the Virgin Islands, we have the Virgin Island Basin, and a little bit further and closer to Puerto Rico, the Muertos Trough. Further west is the Southern Caribbean Deformed Block, and even further west we have the Northern Panama Deformed Belt. To the south of the Virgin Islands, we have the subduction zone associated with the Lesser Antilles. And much further east towards Europe, offshore Portugal, there's a series of faults also that in the past have generated earthquakes and have had tsunamis that have reached the Caribbean and the Virgin Islands. It could be sunny or rainy. It could be the middle of the day or the middle of the night. It could be a weekday or a weekend. It could be a holiday, like it was December 26, 2004, when one of the most horrific tsunamis struck the Indian Ocean and no one was ready. Three of the biggest challenges for tsunami warning in the U.S. Virgin Islands are their infrequency, their rapid onset, and their vulnerability. The relative infrequency of tsunamis are a very big challenge. Unlike hurricanes, significant tsunamis only occur a couple times a century in the Caribbean. In its 500-year history, 83 tsunamis have struck our coast. Of these, 3 to 4 tsunamis have hit the Virgin Islands, and only one, the one of November 18, 1867, with devastating consequences so well documented by Professor Roy Watlington. On this map is a depiction of the tsunamis that have been generated in the Caribbean, Central America, Mexico, and the adjacent regions. The sources of the tsunamis are depicted by the green circles in the case of earthquakes, green triangles, which one can make out a few in the Lesser Antilles, which are tsunamis generated by volcanoes, and then there are also some green squares. You can see one closer down to South America, which are tsunamis that are generated by landslides. Tsunamis generated by earthquakes definitely dominate over tsunamis generated by volcanic eruptions or by landslides. The bars of varying size that are on the map depict the tsunami heights as observed in historical events. And here we can notice one of the largest bars is right on top of the U.S. Virgin Islands with a marker of 16.2 meters. And this was an observation from that November 18, 1867 earthquake and tsunami. Because of their infrequency for years, tsunamis were considered the peligro olvidado, the forgotten danger. But the reality is that infrequency does not protect us. Like with hurricanes, it just takes one to cause a tragedy where hundreds, even thousands of lives can be lost and livelihoods can be decimated yet again. The second challenge is that almost all the tsunamis that will strike the U.S. Virgin Islands are going to be short-fused. Unlike for hurricanes, which give us days of forewarning, the arrival of a tsunami after generation may be only a couple of minutes, at best a few hours. In this map, we highlight the time it takes for a tsunami to reach the Virgin Islands. And you can see right around the Virgin Islands, there is an isochrone that says 30. All the area within this isochrone could be impacted within 30 minutes. And you can see in the closest areas, it could only be as little as, 5-10 minutes. So very short time. The further away the tsunami is generated, the more advanced warning or time the U.S. Virgin Islands will have to evacuate and respond. So for example, if the tsunami were to be generated in the Western Caribbean, you'd have over 2 hours. In the Southern Caribbean, you'd have almost 2 hours. So The further away, the more time you will be, but still, we're talking about a very little time. In fact, the time between the onset and the arrival may very well be shorter than the time it takes the issuance and dissemination of a tsunami warning by the Pacific Tsunami Warning Center. Not only is there precious little time, but at the same moment, the population is probably going to be dealing with devastating earthquake impact. Depending on the day of the week, the time of the day, hundreds to thousands of people would be at risk from being caught up in the strong currents and the inundating waves. These could include local people, kids at school, people on boats, government officials in buildings that are located very close to shore, or tourists that are visiting, coming off cruise ships. But in addition to the risk to life, there's the risk to livelihoods and property. Vessels at sea could be yanked from their moorings and slips and spin around, smashing against each other. Some could be taken out to sea. Buildings in lower areas would be flooded, many weaker ones flattened and taken out to sea. The cascading social, economical, and emotional impact are unfathomable. Thus, our third challenge. But for each challenge, we have a strength, we have a solution. In this case, Tsunami Ready, Kariba Wave, and the UN Ocean Decade Tsunami Program can counteract the challenges. So what can be done? We need to get ready. We need to get tsunami ready. Since 2014, the U.S. Virgin Islands has been recognized by the National Weather Service as tsunami ready, and this means that the territory has taken deliberate actions to assess, prepare, and respond to the next tsunami. In this map, we see the map of the United States and its territories depicting the communities that have been recognized by the National Weather Service as tsunami ready. The picture on the bottom of the screen was taken on the day the official recognition took place in May 2014 in St. Thomas. And in the table, we can see a summary of the guidelines which communities need to meet in order to be recognized as tsunami ready by the National Weather Service. Since 2014, tsunami evacuation maps exist for all the U.S. Virgin Islands, and these clearly show that thanks to the hilly topography and high ground can be reached quickly in most cases. Education and outreach is key to make sure that people understand these areas that are at risk and areas that they should go in case a tsunami hits. In addition, we have tsunami evacuation signs that have been in place in various areas to further advance the education and awareness. And another key component of the educational and tsunami preparedness in the Virgin Islands are the sirens, which complement other communication systems and make people aware of the case of a tsunami. For tsunami warnings, people must be aware that there are both natural warning signs and official alerts. In terms of natural warning signs, a strong or long earthquake, a roar from the sea, or a sudden change of sea level must be heeded like a siren going off, and people should head to higher ground, no questions asked. The Pacific Tsunami Warning Center is responsible for issuing tsunami alerts and information products for the U.S. Virgin Islands. The time it takes them to issue a product can vary from 3 to maybe for some events up to 5, 6, 7 minutes. Then it's the responsibility of the local authorities to then disseminate those messages to the public. It's important to be aware that the Pacific Tsunami Warning Center has 4 types of products that it issues for tsunamis. The warning, which is the highest level of alert, basically means to get out of the evacuation zone. When they issue an advisory, the suggestion action is to get out of the water and off the beach. While for a watch, it is important to stay tuned for more information. A dangerous tsunami may or may not be on the way. An information statement is released when there is no expected threat. People can stay cool unless nature tells you otherwise. Response plans need to be in place so the warnings and alerts can be disseminated as fast as possible, 24 hours a day, 7 days a week. Alert VI and the upgraded network of sirens is an important component of this response. Response plans need to be in place and tested so that the warnings and alerts can be issued as fast as possible, 24 hours a day, 7 days a week. Alert VI and the upgraded network of sirens is an important component of that response, as well as the annual Kariba Wave exercise, which is a perfect opportunity to expand tsunami awareness and also validate tsunami response plans. It's the opportunity for people to practice getting out of the evacuation zones. Kariba Wave is a perfect moment to also test the sirens and other tsunami warning capabilities. March 23, 2023 will be the next Kariba Wave, and one of the scenarios will be of great interest, the eruption of Mount Pelée of Martinique, which triggers a tsunami, because not all tsunamis are generated by earthquakes. Another opportunity for significantly addressing the challenges of tsunamis in the Caribbean and around the world is the UN Ocean Science Decade for Sustainable Development. As part of this decade, which runs from 2021 to 2030, is the Ocean Decade Tsunami Program. This global program is focused on two aspects of the tsunami warning system. The first on improvement in tsunami forecast, and the second in tsunami preparedness. In this graph, we highlight the expected improvement on tsunami forecast time and its quality due to the implementation of new technologies. In this graph, on the x-axis to the left, is the tsunami source uncertainty. So at the top, at the high level, 1 means we really don't have an idea what the source of the tsunami is or the potential, and 0 at the bottom is when we're totally certain about the source and therefore can forecast the waves with very good certainty. And on the bottom of the graph, we see the time lapse between origin time of the tsunamis through over a day. And we show 3 different time lapses or time periods of the tsunami warning system. 2004, when the Indian Ocean tsunami occurred, 2019, which is sort of where we are now, and then our goal for 2030. For 2004, you can see it took us even 45 minutes to even have an idea that a tsunami was generated, and to really understand that source of the tsunamis took up to a day. Nowadays, within 15 minutes, we have a pretty good idea of what the tsunami source is. There's still some uncertainty, but much better than 2004. But still, it can take another hour, 15 minutes, an hour and a half to have a really good grip on that tsunami, on the tsunami source, and then be able to make good forecasts on tsunami wave heights. And as you know, in the Virgin Islands, what we say, a tsunami can reach the Virgin Islands within 10 minutes, 15 minutes, 20 minutes. So 2 hours is a really long time. So our goal is that by 2030, what used to take us a day, now takes us 2 hours, could take us only 10 minutes. So within 10 minutes, we could have a good understanding of the source and be able to make good tsunami forecast. And this will be possible by implementing new technology, integrating existing and new observations. In this slide, I try to summarize all the people that will be positively impacted by an improved tsunami warning system in the Virgin Islands, and that the U.S. Virgin Islands remains tsunami ready. So we have kids in schools, we have our visitors, we have our restaurants and our tourism industry, we have our cargo industry, we have our fishermen, we have the people that just enjoy being on the beach, we have the captains of our ships. So it's a lot of people's lives are at stake. So it's so very important that the U.S. Virgin Islands remains tsunami ready and keeps improving its capabilities. So with these improvements and remaining and further enhancements to the capabilities, U.S. Virgin Islands can definitely overcome the challenges of the infrequency of tsunamis, the rapid onset and devastating effects. So participating in Tsunami Ready, the Kariba Wave, and contributing to the Ocean Decade are key. We may not be able to save everyone's lives, but we will have laid the conditions to respond effectively and serve as many lives as possible. Thank you very much for your attention today. I'm so sorry that I can't take your questions, but Dr. Elizabeth Vanacore and Professor Roy Watlington are online and probably can answer any of the questions you might have. If not, feel free to please reach out to me at krista.vonh@noaa.gov. That's krista.vonh@noaa.gov. Have a great day and stay safe.
So thank you to Deputy Director Von Hillebrand for such an informative presentation. Although she wasn't here, her presentation was very detailed and we definitely learned a lot from her presentation. Before we go to any closing remarks or summarization from myself and Director Joshin, I would like to give a couple of minutes to one of our presenters who was able to join, who has been given a lot of kudos from a lot of you guys throughout the presentation, who is Dr. Jose Martinez Cruzado, who is a professor in civil engineering at UPRM and the director of the Puerto Rico Strong Motion Program. So Dr. Martinez Cruzado, I'll turn it over to you for about 5 to 7 minutes so you can provide any information that you would like to brief the group on and all the viewers as well.
Well, I'm in charge of the Strong Motion Program here in Puerto Rico, and we have plenty amount of instrumentation, about 100, almost 130 strong motion stations in Puerto Rico, Dominican Republic, U.S. Virgin Island, British Virgin Island, and also in Anguilla, we have one station over there. And as you know, most of our a lot of instrumentation was damaged during Hurricane Maria in 2017. And thanks to Elizabeth and the USGS, we got some money, a lot of money to rebuild all the network. And now we were able to get back all those stations, to have new stations also, and now having a lot of stations with solar panels and communication. We have employees that have been getting expert in getting communication with the station. And we have about 90 stations that are continuous recording and communication with the data center at Mayagüez and another data center that we have created at Finca Montaña in Aguadilla. So we have improved a lot our strong motion program these years. And as I was hearing to Jason Penn, we have been also working a lot in U.S. Virgin Island and British Virgin Island especially, because of the Hurricane Irma that destroyed almost all the stations as British Virgin Island, BVI. Only one station was still working after the hurricane, was the one at Virgin Gorda. And so we got money to rebuild all that seismic stations, and we got more than we have before. So we have been able to install new station at different islands, Guana Island, Peter Island, and to increase the instrumentation in the area of British Virgin Island. So, and actually we're planning to go maybe on December to re-instrument the control tower, the one that was also destroyed because of the Hurricane Irma. Okay, so we have been pretty busy and we are enjoying a lot all this stuff. So let's see what else we have in our hands. Next week I'm also traveling to Dominican Republic. There will be a conference over there about a school. They want to rehabilitate their school in the whole country. So something that is being done here also in Puerto Rico. So we are going to have some conference over there in Puerto Plata. That, you know, that they have an earthquake in 2003, 6.2 magnitude earthquake. They got was something like that, and destroyed about 4 schools over there. So next week I will be there. So I don't know if you have any questions for me.
much, Dr. Martinez Cruzado. We're definitely going to do another portion where we're going to ask the viewers who watch this workshop to ask questions. And at that point, we're going to bring the group back together and answer those questions and make it a little bit more interactive as best as we possibly can. But thank you for providing those brief remarks, because we wanted to make sure, since you were on, that you were able to provide the viewers with everything that you're working on and all of the progress that we're making throughout the Caribbean, working together as partners. So thank you to all the presenters who participated in this presentation today. It is not going to be the last one. We definitely want to continue to build on top of this, because we know throughout the territory, there's a lot of seismic risks that you each mentioned, and the community wants to learn more about just awareness, outreach, education. So we're definitely urging all viewers to listen to each of these presentations, go to all of the websites that they mentioned, learn the resources, reach out to VITEMA. If you're in the British Virgin Islands, reach out to Director Penn. If you're in Puerto Rico, reach out to Dr. Vanacore, Dr. Martinez Cruzado, PRSN, anyone that was on here that provided information, as well as Ms. Shumway, who provided a lot of information on USGS. And as they mentioned, if you do feel the earthquake, please log into the resources that they mentioned and let them know all of the information. Please ask us whatever questions that you have. All of these subject matter experts are willing to come back together as a group to answer those questions as best as they possibly can and provide those resources and education to the public. I'll now turn it over to my director, Joshin of VITEMA, so he can provide closing remarks and provide a summary of today's USVI Seismic Workshop.
Well, it's been a last couple hours, very good information from our subject matter experts, and thank you all for bringing your areas of expertise. And Regina, thank you for the facilitation. You know, always we talk about what can you do as participants to this this venue for seismic activity. We mentioned already, Dr. Valancourt mentioned a great shakeout exercise drill happening in Puerto Rico coming up on October 20th at 10 o'clock in the morning. We will have one here also in the U.S. Virgin Islands at 10:20 in the morning on the 20th of October. So I think those drills or activities you can get involved with, either individual, a family, a school, a business, to take action back to that drop, cover, hold on, and then if you're going to evacuate, develop an evacuation location to go to for accountability and learn from that, develop a plan of action for your community is so important. We've heard about discussions. You really can't, in this area of the Caribbean, whether it's Puerto Rico, U.S. Virgin Islands, or Puerto Rico, you can't really separate earthquakes from tsunamis. Then we heard a lot of information going back and forth about how they interact with each other. Just because you have an earthquake does not mean you're going to have a tsunami. And also we have indications you're going to have potential like other events such as Tonga happened last year in the Pacific, and we do have volcanic activity here in the Caribbean that could generate a tsunami also. But I think it's the information sharing. We talk about resiliency. That term's gone about quite a bit for the last couple of years, whether we're recovering from hurricanes in Puerto Rico or it could be earthquakes in Puerto Rico. Virgin Islands obviously are impact of hurricanes, and the Virgin Islands are hurricanes. You know, we have to go back and rebuild things better to be able to get the information back together. So I appreciate on the academic side, the funding side, to get those environments going again. We now have our 44 tsunami sirens being built back here in the territory. We're testing those and drilling those. I know Puerto Rico has tsunami sirens. I know also in the British Virgin Islands. So it's sirens, it's seismic activities, it's working together in the community, going back together to go back to that foundation of saving lives and preserving property. And I think the outreach is so important as a community. We ask questions, we become informed. And even though we're in 2022, we want to look at for the history and the future, look at those models that can predict out. I would love to see the 1867, earthquake, tsunami impact and that model to see what would happen today in 2022. Because you're going to have more building out of roads, of schools, of tourism, of housing communities. So we want to have that information shared as we develop the code changes to make our structures more protective. You see what's happening in California, in Japan. For years, they've built those codes. So I think part of this education is understanding back to the codes that build our environments, our structure much better to withstand anything that may come, either being an earthquake or a tsunami or a hurricane. If we can cover all three of those, it covers the majority of the threats there are in our area in the Caribbean. So again, thank you, everybody. Please submit your questions so we can answer those as subject matter expertise and overall raise the bar of education and awareness in the Caribbean. So thank you all.